Hello. Good evening, everyone. If you could please take your seats, we'd love to get started with the evening. We've got some really great awards to give out and some really wonderful people to honor. For those of you who don't know who I am, I'm the AIAA Executive Director, Sandy Magnus. I'd like to welcome you to the 2017 AIAA Aerospace Spotlight Awards Gala. And thank you all so much for coming. And thank you for taking your seats. We're really excited to have all of you here as we come together year after year to celebrate all of the wonderful things that our community has been doing. This evening is truly a community celebration. We honor the best and the brightest, the people who are shaping the future of aerospace every day. Everyone in this room has a lot of dedication to the industry, reflecting the passion that our whole community feels. The ingenuity, the talent, all of the things that we do to help shape the future of aerospace. Big ways, small ways, we have so many exciting projects going on. And tonight, we recognize and honor award winners who exemplify aerospace, ingenuity, collaboration, excellence, the work, research, and discoveries that fuel the collective human drive to explore, create, and be part of something bigger than ourselves. And I think that's what drives us to this industry, the fact that the projects and things that we do are so much bigger than us and we're a part of doing great things. We share this commitment to inspire, we share the commitment to innovate, and stand as testimonies to what humans can do, and we put our minds to it. This year, we are honoring, as usual, a bunch of people. We added, as every other year, we add educators to the mix, and we have 5 great, amazing educators who are teaching STEM in classrooms across the US and Canada. Some of the students that they enlighten, encourage, and engage may very well become some of the people that we honor here on the stage in the future. And I think, I'll just go off script for a moment. I think educators are an underappreciated profession in our industry. They have so much impact on students on a day-to-day basis, and we really are delighted. Yeah, let's give them a round of applause. We are very delighted to honor these outstanding educators here at our Gala Awards every other year. So we're going to get the evening started. Thank you all for sitting down so nicely. That's usually the hardest thing to do. You're just wonderful. So we're going to get started with a really great evening. In just a few moments, an Armed Forces Color Guard from the U.S. Military District of Washington will present the colors, followed by the singing of the National Anthem by Sergeant Vicki Golding from the 257th Army Band of the District of Columbia National Guard. So if you would please rise, we will continue with that.
Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Let's give her a round of applause. That's excellent. Thank you so much. Please be seated. Tonight, as I look across the room, it's very exciting to see so many distinguished representatives of industry, academia, government, and the military. Really, we have, someone asked me earlier who I thought the most interesting people were here tonight, and I said the whole crowd, because there's such a great representation of all of the exciting things going on in the industry. And I want to thank each of you for being here on behalf of AIAA, and thank you for participating in this awards gala tonight. Also, you know, the evening, I think, represents a wide, diverse range of people and areas that operate in our industry. You know, we have a lot of passion, we have a lot of intelligence, we have a lot of desire to apply those things, and all the great minds in this room and the companies and academic units and government institutions that you represent really show that when we come together, all the wonderful things that we can create to make the world a better place. We have big companies, small companies, national labs, think tanks, people who work here in DC on the legislative and executive processes, people who work in the states. Your cutting edge work is the future of our industry, and the students that we inspire are those that come behind us to build on what we do. We have nonprofits that we partner with, we have NGOs that we partner with, all of us working together to make our industry stronger. We have domestic and international partners as well, and we know that we're a very global industry, and we find ways to work together and make things that are just truly spectacular. I would like to invite now Jim Mazur, AIAA President Jim Mazur, to the stage, and he will introduce our Fellows Class of 2017.
Thanks, Sandy. Wow, what a good-looking crowd out there. I thought it was good-looking last night, but you guys are looking great tonight. It's really exciting to be here. You know, so we had the official Fellows Dinner last night, and it was great. I mean, an incredible collegiate atmosphere, and a lot of camaraderie, and a lot of celebration about becoming a fellow, because it's a really big deal, and an honorary fellow, which we'll do after dinner. But the thing that struck me was, as you listen to the citations, the complexity of the stuff people are working on. So I pulled out some key phrases, because I just want you to hear some of this. Optimally efficient architectures for spectral and spatial filtering. Span technical areas from optimal control and differential games to nonlinear control to robust and adaptive control to stochastic systems and network systems. Pioneer modern micro-vein and microjet boundary layer flow control. Contributions in the area of estimation, filtering, data fusion, and signal detection. And when I think about this, so when I wrote my thesis, I used parametric in the title, and I thought that was really complex, and I'm a little embarrassed and humbled to be in the room with you guys, to be honest. But the one I don't know, it got me thinking. It was called Technical Contributions in Probabilistic Analysis, Uncertainty Quantification, and Model Validation. So I'm sitting there, you know, he's walking up to the stage, and so the question that came to my head was, if you're highly accurate in quantification of uncertainty, does that mean you're certain? and I guess that's why I'm in management now. In a few minutes, we'll present our new fellows to you. But one of the things I want to talk about, too, from last night is we had a fellow, Norm Abramson, who joined the Institute of Aeronautical Sciences in 1947. And we gave him his 70-year pin last night. And he walked up to the stage and squeezed my hand like any 30-year-old could. So it was just incredibly impressive. And afterwards, I commented that I only have 40 more years to go. So it was truly impressive and inspiring. So in a few minutes, we'll present our new fellows to you. And as many as you know, being elected an AIAA fellow is a significant honor bestowed upon persons of distinction who have made notable and valuable contributions to the arts, sciences, or technologies of aeronautics or astronautics. Fewer than 5% of AIAA members are ever named fellows, and since 1934, we've only installed 1,800 distinguished individuals to the ranks of AIAA fellow, and we have fewer than 750 active in the ranks today. But before I honor the class of 2017, I definitely want to acknowledge the work of Fellows Selection Committee chaired by Paul Kaminsky, and thank the committee for a job well done. And now I'm pleased to introduce our 2017 fellows. Now this is interesting because I've been coming to this for many years, and it says, please hold your applause until all the fellows have been introduced. I don't care about that at all. Hoot and holler as much as you want. We're here to have fun. Okay, our first fellow to be recognized is Naval K. Agrawal for sustained innovative contributions and leadership in aeroacoustics, airplane acoustics, and measurement techniques that contributed to aircraft noise reduction. Dr. Agrawal is a technical fellow at the Boeing Company in Seattle, Washington. He's an internationally recognized expert in aeroacoustics, airplane noise, and measurement methods for wind tunnel and flight test applications, as evidenced by his numerous publications. He has developed several technical papers used by industry and holds numerous U.S. and world patents. Our next fellow is Carl D. Villamoria for outstanding contributions advancing the research and development of the next generation air transportation system. He's a research aerospace engineer at NASA Ames Research Center in Moffett Field, California, and he's also editor-in-chief of AIAA's Journal of Air Transportation. As an aerospace researcher at NASA Ames for over 20 years, he has made outstanding research contributions in the area of air traffic management. This work has received wide recognition in the international research community and has earned him several prestigious awards from AIAA, FAA, and NASA. Our next fellow is Thomas C. Butash for the advancement of state-of-the-art flexible communication, satellite and intelligence, surveillance, and reconnaissance systems design, analysis, and performance. Dr. Butash is an aerospace systems consultant and founder of Innovative Aerospace Information Systems in Centerville, Virginia. For more than 3 decades, Dr. Butash's innovative developments have increased the capabilities and performance of communication satellites and intelligence, surveillance, and reconnaissance systems. His contributions, which have earned 4 U.S. patents, include inventing optimally efficient architectures for spectral and spatial filtering and routing of signals in multi-beam cell, multiple access communications, and ISR systems. It's a little tougher than parametric. These inventions facilitated Asia Cellular Satellite, the world's first satellite-based cellular communication system, providing cellular service to Asia and the Western Pacific region. Our next fellow is Njan Davis for exemplary contributions to design of the Hubble Space Telescope, hardware and payload operations of the International Space Station, and enhancements to the safety of human spaceflight and service as a NASA astronaut. Dr. Davis is Vice President Deputy General Manager for Jacobs in Huntsville, Alabama. As an engineer, astronaut, and executive, she has made significant contributions to the safety, hardware, operations, engineering, academic research, and management of our nation's human spaceflight programs. Dr. Davis has been an executive at Jacobs for the Marshall Space Flight Center Engineering Services contract since 2005. The other thing I learned last night is we have groupies, which is kind of cool. So the next fellow is unable to join us this evening, but we do want to recognize him. Ari Glezer for groundbreaking contributions to the understanding, application, and actuation strategies of active flow control and aerodynamics, educating outstanding students and research community leadership. Dr. Glezer holds the Woodruff Chair in Thermal Systems at Georgia Institute of Technology in Atlanta, Georgia. He has made pioneering contributions to the understanding and applications of active flow control and aerodynamics, the education of outstanding graduate and undergraduate students, the development of major U.S. government-sponsored active flow control research and development programs, initiation of successful collaborative active flow control research between academia, government, and industry, and leadership within AIAA. Let's go ahead. Our next fellow is Stephen F. Griffin for pioneering research in adaptive structures and vibration management, technology demonstration, and risk reduction for operational flight systems and service to AIAA and higher education. Dr. Griffin is a senior technical fellow and chief engineer, Maui Space Surveillance Systems at the Boeing Company in Hawaii. He has distinguished himself as an international technical authority on adaptive structures, structural dynamics, and vibration management, one who's made valuable contributions to precision in space. Dr. Griffin joined Boeing in 2000, where he co-developed an integrated modeling tool that supported the development of many spacecraft and terrestrial systems, including the Advanced Tactical Laser, the world's only successful demonstration of a high-energy laser in a tactical mission, for which he was also responsible for the structural dynamics design. Our next fellow is Naira Hovakimyan for pioneering development of technical knowledge and robust adaptive control in its transition to aerospace and commercial applications. Dr. Hovakimyan is the W. Grafton and Lillian B. Wilkins Professor of Mechanical Science and Engineering at the University of Illinois at Urbana-Champaign in Urbana, Illinois. She's a co-founder and chief scientist of Intel and Air, a company that delivers actionable intelligence to farmers from aerial information collected onboard UAVs. For the past 25 years, her contributions have spanned technical areas from optimal control and differential games to nonlinear control to robust and adaptive control to stochastic systems and network systems. Our next fellow is Eric Loth for seminal contributions in aerodynamics of supersonic inlets, aircraft icing, and wind energy, and for extraordinary leadership in aerospace education. Dr. Loth is the chair of mechanical and aerospace engineering and Rolls-Royce professor of engineering at the University of Virginia at Charlottesville, Virginia. He has made seminal contributions in supersonics, including leading the 2 largest NASA supersonic inlet tests of the last 20 years. Dr. Loth's new research in morphing wind turbines resulted in an invitation to Capitol Hill in March 2017 and at the University of Illinois in Virginia, and he has significantly enhanced the academic excellence and diversity of the aerospace students while developing state-of-the-art curricula. Our next fellow is Frank K. Liu for sustained contributions in gas dynamics and detonation-based technologies and development of novel experimental facility and measurement techniques. Dr. Liu is a professor and director of the Aerodynamics Research Center at the University of Texas at Arlington in Arlington, Texas. He is being recognized for significant achievements in high-speed aerodynamics, propulsion, and application of detonation technologies to propulsion. Dedicated efforts in aerospace education, extensive publications of aerospace books and technical articles, and extensive service to AIAA and the aerospace community. Dr. Liu's leadership has propelled the University of Texas at Arlington into the forefront of aerodynamic research through his team's work in gas dynamics, hypersonic, air-breathing propulsion, and detonations. Our next fellow is Roger P. McNamara for outstanding technological innovation and leadership in the development and flight test of the next generation manned spacecraft, technical contributions to orbital debris, environment characterization, and exemplary service to AIAA. Dr. McNamara is the Director, Orion Launch Abort System, Exploration Flight Test 1, Ascent Abort 2 at Lockheed Martin Corporation in Denver, Colorado. His notable contributions include early research into characterization of the hazards of orbital debris to space vehicles and operations and potential mitigation strategies. In improvements in space vehicle design and development, both manned and unmanned systems, and most significantly, leadership in advancing technological innovation for human deep space exploration. Our next fellow is Daniel N. Miller for pioneering aerodynamic contributions to modern flow control, aero-optics, and propulsion integration technologies that deliver revolutionary aircraft capabilities and for exceptional leadership in AIAA education. Mr. Miller is a highly respected technical leader in the aerospace industry who is world-renowned for his notable and pioneering contributions in two major areas: modern flow control technology and innovative application to design novel aircraft configurations with revolutionary capabilities. As the Skunk Works principal investigator of the DARPA Aero-Optic Aero-Adaptive Beam Control Program and a senior fellow at Lockheed Martin, Daniel led the demonstration of a first-of-its-kind, full-scale, transonic, hardware-in-the-loop system to meet extremely demanding requirements. Our next fellow is Gary F. Polanski for sustained and diverse contributions to the aeronautics and space communities, enabling advanced hypersonic flight systems and safety for space nuclear power-enabled missions. Dr. Polanski is a senior scientist at Sandia National Laboratories in Albuquerque, New Mexico. He has made significant and long-lasting contributions to aerospace systems applications through research, development, integration, and management of advanced flight systems technology. Throughout his career, Dr. Polanski has been an acknowledged leader in aerospace nuclear safety. He has advised the Interagency Nuclear Safety Review Panel in the launches of Pluto New Horizons and the Mars Science Laboratory. Our next fellow is Richard W. Powell. In recognition of exemplary career of technical contributions leading to the successful developments and operation of both Earth and planetary entry systems. Mr. Powell is a senior research engineer at Analytical Mechanical Associates Incorporated in Hampton, Virginia. He is an internationally recognized expert in the field of guidance and control and trajectory design and assessment for vehicles that fly through atmospheres such as entry, aerobraking, and aerocapture. Dr. Powell worked on the Space Shuttle program from the beginning of Phase B through the return flight after the Challenger accident. He led the development of a pilot-in-the-loop simulation that he used to evaluate the effects of aerodynamics uncertainties on guidance and control performance. Our next fellow is Mark L. Saiki for distinguished contributions to the theory and practice of estimation and data fusion for satellite attitude and orbit determination, as well as GPS signal processing. Dr. Saiki is the Kevin Crofton Faculty Chair in Aerospace and Ocean Engineering at the Virginia Polytechnic Institute and State University in Blacksburg, Virginia. His contributions lie in the areas of estimating, filtering, data fusion, and signal detection, with applications to spacecraft attitude and orbit determination, global positioning system, and global navigation satellite system signal processing and remote sensing. The majority of his recent work is in the area of GPS, GNSS signal processing. Dr. Saiki developed several important GPS, GNSS signal processing algorithms. One set of algorithms has been used in a NASA-designed high-altitude GPS receiver that acquires main lobe and weak side lobe signals onboard spacecraft which fly above the GPS constellation. Our next fellow is Lisa B. Rowe. She had the most groupies last night. For sustained, unparalleled personal contributions from initial pathfinding experiments for the International Space Station to breaking barriers to integration and policy critical to the nation's aerospace program. Ms. Rowe is the acting deputy administrator and the deputy associate administrator at NASA headquarters in Washington, D.C. She is an outstanding leader in the aerospace industry. As a top government senior executive with significant and lasting impact on the nation's aeronautics and space future, her career spans 30 years at 4 NASA centers and with industry where she has significantly influenced the aerospace profession, her community, and national policy. Ms. Rose removed barriers to new frontiers, creating fertile opportunities for affordable space exploration and greener and quieter air travel. Our next fellow is the Honorable Heidi Shyu. For exceptional performance as a national security scientist, engineer, and system manager in the aerospace industry and at the highest levels of the U.S. Department of Defense. Ms. Shyu is the former Assistant Secretary of the Army for Acquisition, Logistics, and Technology and the founder of the Heidi Shyu Incorporated in Arlington, Virginia. She led the execution of the Army's acquisition functions and the acquisition management system. Her responsibilities included providing oversight for the lifecycle management and sustainment of Army weapon systems, mobility systems, electronics, software, and other products. Ms. Shyu also oversaw elimination of the Army's chemical weapons program. She is unquestionably one of the Army's most knowledgeable experts in rotary wing aviation and is a vocal advocate of Army's aviation, air defense, missile defense, and space support of the ground and airborne forces. Our next fellow is George F. Sowers for outstanding and sustained contributions to the development and operation of space launch systems critical to national security, commercial, and space exploration interests of the United States. Dr. Sowers was the Chief Scientist and Vice President of Advanced Programs at United Launch Alliance in Centennial, Colorado, where he recently retired. He is now in the process of forming his own space consulting company. Dr. Sowers' valued contributions span more than 3 decades. He has contributed to the resolution of many technical issues and wrote several physics-based analysis codes for problems ranging from the venting of gas mixtures from the payload fairing to the simulation of the liftoff acoustics field generated by a launch vehicle. He was a chief systems engineer for the development of Atlas V launch system. His most notable contributions lie in spacecraft launched by the rockets he's developed and operated. Our next fellow is Ben H. Thacker. For exceptional leadership and technical contributions in probabilistic analysis, uncertainty quantification, and model validation for longstanding service to AIAA, we have to talk. Dr. Thacker is the Director of Materials Engineering at Southwest Research Institute in San Antonio, Texas. He was recruited to work at Southwest Research Institute in 1988 to join a small team charged with developing new methodologies in computer software, later named Nessus. It was used for assessing the probabilistic response of Space Shuttle main engine components using high-fidelity computer simulations. Dr. Thacker developed and implemented several highly efficient probabilistic analysis algorithms, numerous interfaces to commercially available finite element analysis codes, and designed the sophisticated Nessus graphical user interface. Our next fellow is John Vlasic. For pioneering contributions and outstanding leadership in flight mechanics and control, leading to new capabilities in autonomous air refueling, morphing flight, and flight safety. Dr. Vlasic is a professor, aerospace engineering, and director, Center for Autonomous Vehicles and Sensor Systems at Texas A&M University in College Station, Texas. Throughout his career, Dr. Vlasic's research has focused on bridging the scientific gaps between traditional computer science topics and aerospace engineering topics with his unique systems approach and his ability to seamlessly integrate different disciplines such as dynamics and control, artificial intelligence, and bioinspiration. I like that. He has been instrumental in advancing the academic UAS research and flight testing as one of the first 2 professors in the United States to conduct UAS research flights under full FAA compliance. Our next fellow is Julie A. Van Cleek. For exceptional technical contributions and visionary leadership in the design, development, and operation of space and missile propulsion systems for U.S. and international applications. Ms. Van Cleek is a Vice President, Advanced Space Programs at Aerojet Rocketdyne in Sacramento, California. Her contributions to the science, technology, management of propulsion systems have impacted virtually all forms of rocket propulsion technology and their applications, from sounding rockets to missile defense to launch and in-space systems spanning liquid, solid, and electric propulsion systems and technology. The next fellow wasn't able to join us this evening, but we would still like to recognize him. Todd W. Zarfas, for exceptional leadership in advancing systems technology for commercial airplanes and for dedicated industry support to higher education. Mr. Zarfas is the Vice President, Engineering Functions, Washington State Design Center, and the Senior Chief Engineer Systems at the Boeing Company in Seattle, Washington. He is a pioneer in advancing systems capabilities through information technology for commercial airplanes. This has resulted in a number of significant achievements that have advanced the state of aviation and airline technology. All right, so let's congratulate this group's 2017 AIAA Fellows. All right, fellows, please return to your tables, and we'll sit down to dinner and carry on with the program after dinner. Thank you very much. Thank you.
Please welcome back to the stage AIAA President Jim Mazur and AIAA Executive Director Sandy Magnus.
Wow, that was awesome. You guys just sort of naturally quieted down before I said anything. I hope you enjoyed your dinner. I know we did at Table 1. I think part of the enjoyment of evenings like this is a chance for us to catch up with old friends, make new friends, and socialize a little bit, as well as do the award recognitions that we do to celebrate excellence in our community. So I think everyone had a good time. But it's time to continue our celebration of the best in aerospace by beginning the Spotlight Awards portion of the evening. As is our tradition, each award will be introduced by a short video explaining its history, showcasing the recipient, and highlighting some of the accomplishments of the recipient. After the video, we will then call the recipient to the stage to make remarks and receive their award. And we'll start with the honorary fellows. So I believe you have a video to play.
The title of Honorary Fellow is the highest distinction conferred by AIAA, recognizing preeminent individuals who have had long and highly contributory careers in aerospace. The institute named Orville Wright its first Honorary Fellow in 1933. The 217 names added in the subsequent 84 years comprise a veritable who's who of our community's brightest stars. To become an Honorary Fellow, members must have been selected by their peers as an Associate Fellow, and then a Fellow, meaning that the title of Honorary Fellow is a lasting testament to the legacy that each recipient has forged in aeronautics and astronautics. Less than 1% of AIAA members achieve this honor. Tonight, we salute 3 new Honorary Fellows. Natalie W. Crawford, Senior Fellow at the RAND Corporation, for a professional devotion to the U.S. Air Force through unwavering commitment to optimally integrate technology, the warfighter, and operations through critical thinking, candor, objectivity, independence, and thoroughness. Dr. Alan H. Epstein, Vice President of Technology and Environment at Pratt & Whitney, for exceptional contributions to aircraft propulsion, innovative turbomachinery experimentation, compressor instability control, microengines, and for technology strategy creation and implementation for a major aero engine manufacturer. And Dr. Bradford W. Parkinson, Professor Emeritus at Stanford University, for leadership in aerospace engineering, including the development and application of the Global Positioning System. Congratulations on this noteworthy achievement.
So as you've just heard, Honorary Fellow is the highest honor that we bestow at AIAA. Only 200 people since 1933 have been named as Honorary Fellow. Less than 1%, I just want to highlight that, less than 1% of AIAA members have ever achieved this rank. So it's a very, very special honor. And I think for the Fellows Awards, the Honorary Fellow Awards, and the awards that we give tonight, the importance of these awards is that you're being recognized by your peers for your contributions to the field. And who better than to judge the value of your contributions than those of us sort of in the know, right? Those of us who are your peers. So congratulations again to our fellows, and we'd like to call our honorary fellows to the stage one by one. But before we start, we want to thank the Honorary Fellows Selection Board. They worked very hard to select the honorary fellows and keep this tradition going of excellence. This year it was chaired by A. Thomas Young. Unfortunately, he's not here tonight, but let's give the committee a round of applause for their outstanding job. So the first honorary fellow this evening is Natalie W. Crawford for professional devotion to the U.S. Air Force through unwavering commitment to optimally integrate technology, the warfighter, and operations through critical thinking, candor, objectivity, independence, and thoroughness. Ms. Crawford is a senior fellow and distinguished chair in Air and Space Policy at the RAND Corporation in Santa Monica, California. She has been a stalwart champion of the U.S. Air Force and for the need to have robust government investment in research and development. From her work ensuring that our nation's attack aircraft have the proper night fighting capabilities to her avionics architecture work that became the F-22 Raptor, to leading studies that help determine the Air Force strength and the appropriate forces mix for the next several decades, Ms. Crawford has devoted her career to ensuring that our nation's air defense are state-of-the-art and able to achieve dominance over a vast range of threats. Due to Mrs. Crawford's length of service and her counsel to numerous secretaries of the Air Force and Air Force chiefs of staff, many of her contemporaries regard her as the mother of the Air Force. Unfortunately, Natalie could not join us tonight this evening, but Jim Mazer was asked to accept her award on her behalf. And so I'd like to invite Jim to the podium for the comments.
Thank you. So Natalie sent some written comments. It's with great regret that I can't be here tonight to accept this extraordinary award. What you don't see are the spirits of people like yourselves and many others who have mentored and taught me all of the years of my career. I did not arrive at this place in life alone. Were it not for all of you, I would not have even been considered for this award. Considering that the only thing I knew about the Air Force when I started my career was that they flew airplanes, I truly needed all the mentors I've had. They have come from the United States Air Force, industry, academia, the RAND Corporation, each of the services, the Air Force Scientific Advisory Board, and countless individuals. Wingman is a common term for one who flies alongside an individual to enrich and enable the success of the mission they are on while providing mutual support through every phase of the mission, never asking for thanks, but welcoming the opportunity to participate. A few years ago, a senior Air Force officer referred to me as her wingman during a very difficult time in her life. I have never forgotten that and how much it meant to me. Each of you is my wingman. That officer was General Ellen Palakowski. I can easily say that every day has been and remains a school day during my career. I've never forgotten that I can and need to learn from everybody. I remember your names, where you work, and the circumstances that produced the lessons you taught me. I've never forgotten that humility is an important way to say thanks. And trying my hardest to do the best I can to support those who put their lives on the line for all of us each day is what I owe those for whom I do my work. Thank you for the opportunities and your patience. I will never let you down. You have touched my soul today. Thank you. Let's
And she was actually very disappointed that she couldn't come, and she sent the comments and wanted to make sure that we read them off, so she's here in spirit, I think. Our second honorary fellow tonight is Dr. Alan Epstein for exceptional contributions to aircraft propulsion, innovative turbomachinery experimentation, compressor and stability control, micro-engines, and for technology strategy creation and implementation for a major airline or an aero engine manufacturer. Dr. Epstein is the Vice President Technology and Environment at Pratt & Whitney in East Hartford, Connecticut. He has devoted his professional career to ensuring that aircraft can fly further, faster, and greener than have been possible before. Dr. Epstein has performed significant work in nearly every area of propulsion system development, including carrying out innovative turbomachinery experimentation, developing methods to mitigate compressor instability, designing novel microengine technology, and creating and implementing technology strategies for Pratt & Whitney. Due to his visionary thinking, creativity, and disciplined work, he is considered one of the best, if not the best, gas turbine experimentalist in the world, pioneering numerous technical advances in propulsion technology. Many credit Dr. Epstein with the invention of the field of smart engines. He regularly advises a number of government, industry, and academic advisory bodies, including the National Research Council, the Defense Advanced Research Projects Agency, and the U.S. Army. Alan, please join us on the stage.
Thank you. Looking at that video, look, I'm not Orville Wright. And like most of us here, our success is based upon that of our colleagues, our students, our partners. But what really makes this special for me tonight is the other two honorary fellows. Natalie Crawford, I first met 40 years ago when I was sent across the country to talk to this very influential, very important senior Air Force advisor, and I had great trepidation. Of course, I now realize she was in her early 30s, but she seemed very senior to me then, and she was certainly well regarded then. And what I was struck by was both her wisdom, but also her kindness in treating a very junior person with great respect. And over the decades since then, I've depended upon her for advice. The other person is Brad Parkinson, whose accomplishments have literally changed the world. And not only have they changed the world, they've changed my life. When I now drive around and am obviously lost, I don't have to ignore the very kind instructions from my co-pilot to, why don't you really just stop and ask directions? My GPS system actually tells me where I am. So, for a guy who's spent his career basically blowing hot gas, I'm actually humble this time. Thank you. Thank you.
Congratulations.
Thank you.
Thank you, Alan. Congratulations. We now recognize our third honorary fellow, Dr. Bradford W. Parkinson, Colonel, U.S. Air Force, retired, for leadership in aerospace engineering, including the development and application of the Global Positioning System. That's just one sentence, but when you think about what that one sentence means, it's really huge, as Alan was referring to. Dr. Parkinson is the Emeritus Professor of Aeronautics and Astronautics and the Emeritus Edward C. Wells Professor in the School of Engineering at Stanford University in Palo Alto, California. He led the design, advocacy, development, launch, and initial tests of the Global Positioning System, or GPS, generally regarded as one of humanity's great innovations. As a colonel in 1972, Dr. Parkinson was selected to lead the struggling Air Force program 621B that had failed to gain approval. After reformulating the program, based on a 1966 Aerospace Corporation study, he won approval for complete demonstration in 1973. With his hand-selected team of engineers and contractors, they successfully demonstrated the GPS prototype by 1978, and it became fully operational in 1995. With over 2 billion users, GPS is now indispensable for positioning, contributing over $60 billion annually in the US in productivity gains. Beyond that, he also directed Stanford's GP-B program, the first direct mechanical measurement of Albert Einstein's general theory of relativity. In 2003, Dr. Parkinson was named co-recipient of the Charles Stark Draper Prize, the engineering profession's equivalent of the Nobel Prize, with Dr. Ivan Getting, for their contributions to the development of the GPS system. Dr. Parkinson's outstanding work provides navigation for the world while also confirming a fundamental law of the universe. Brad, please join us on stage.
I always enjoy these fellowship meetings followed by this banquet. This is really, I think, the highlight of any professional society. I'd like to thank the members of AIAA who nominated me, and thanks particularly to those who got into the business of selecting me, etc. It is indeed a distinguished honor and one I will always cherish. The applications of GPS have even surprised me, and I'm a zealot from the very start. The recent study that showed that GPS provides over $55 billion a year to the United States alone, I think is quite noteworthy. Of course, the fundamental reason I think that we ever had the system was a young Air Force team that I'm very proud of. They provided that accuracy and that capability. And I'm often asked, well, what was that all about? What were those guys all about? Gals. Had a few gals, mostly guys then, but we're getting it better. There's a granite stone outside LA, the LA railroad station. It's a sundial, and it has 3 distinct phrases that I think represent that team. 1, the vision to see. They could see what we needed to do. 2, the faith to believe. They thought we could pull it off. And 3rd, the courage to do. So I'm in great debt to those young people, contractors, Aerospace, my Air Force officers. But I'm equally proud of something else, and we often forget that. I know there are some Air Force officers in the room. Every day, 24 hours a day, 7 days a week, there's a team, 4 to 6, young sergeants, company-grade officers who operate GPS and make it 99.99% available and with a ranging accuracy of about 2 feet. We are indebted in this room, I am indebted to that wonderful Air Force team who day in and day out provide that capability. And I propose just give them a little round of applause. So I want to thank you for this award, but I have to thank you for one other thing that you're not aware of. 40 years ago this year, there was a banquet like this, an AIAA banquet in this city, and that was where I met my wife. Thank you.
Congratulations. Okay, I'm going to go that way. Thank you, Brad. Congratulations. One more round of applause for our 3 new honorary fellows. Truly outstanding individuals. Okay, we're going to now see the video for the Distinguished Service Award.
Established in 1968, the AIAA Distinguished Service Award was conceived by the Board of Directors to give unique recognition to an individual member of AIAA who has provided distinguished service to the Institute. The recipient must be a member in good standing who has shown particular dedication to the interests of the Institute by making significant and continuing contributions. Past recipients of the Distinguished Service Award include James J. Harford, Dr. L.S. Skip Fletcher, Dr. Michael Yaramovich, Roy V. Harris, Jr., and Dr. Tom D. Crouch. This year, the award honors Dr. Robert C. Wynn, AIAA Fellow and Chairman of the Board, Principal and Director of Aviation at Engineering Systems Incorporated, for his over 3 decades of exemplary service and leadership to AIAA, including 11 years on the Board of Directors, as Director at Large, as Vice President Technical Activities, and as Vice President Finance. An AIAA member since 1977 and a Fellow since 2006, Dr. Wynn has shown unwavering commitment to the Institute, serving in a variety of leadership roles. Among the other positions Dr. Wynn has held over the years are Trustee of the AIAA Foundation, Vice President Finance, Director at Large, Vice President Technical Activities, Deputy Director Technical Activities Committee Energy Conversion, Chair of the Technical Activities Committee's New Initiatives Subcommittee, and Chair of the Terrestrial Energy Systems Technical Committee. Dr. Wynn has also served as the Secretary and Vice Chair of AIAA's Rocky Mountain section. He is currently a member of the Investment Subcommittee and the Ethics Committee. He is also an AIAA Distinguished Lecturer.
Well, I got into aerospace almost by accident. I was a mechanical engineer, and I was finishing my master's, and I was about to be drafted, and I started looking around at other services, and clearly the Air Force was the place for me to be. So I signed up to be an engineer in the Air Force, and before I got down to officer training school, they told me, you know, we have enough engineers. Do you want to be a pilot? And I said, okay. So I became a pilot in the Air Force, and I flew for many years, many airplanes, many hours, and then got a chance to teach at the Air Force Academy, where I flew as well as taught aeronautical engineering. And that was wonderful, because now I'm able to tie operational work in with the academic side of things. Great preparation for the rest of my career. Being involved with AIAA for going on 40 years has been wonderful. It has provided me an opportunity to meet some incredible people and learn from them. And it also gave me some opportunities to really do some leadership in a different environment than certainly the military and also in the civilian world. And so I've learned a lot on how to achieve that, and that has played over into my civilian role as well. The work that I do outside of AIAA is forensic engineering. So I get involved in a lot of defense of aerospace companies who have been sued. And the beauty of it is I'm able to really determine what did happen, what was the cause of an accident, and that is extremely rewarding. And it's not always the same as what the NTSB came up with, and that's also rewarding. What does this award mean to me? A lot. I look at the people who have won the award in the past, and I'm truly humbled. It's a list of who's who in AIAA, and to be considered among them is just fantastic.
So we'd like to invite our 2017 AIAA Distinguished Service Award winner, Dr. Robert Wynn, Chairman of Board and Principal and Director, Aviation and Engineering Systems Incorporated in Colorado Springs, Colorado, to join us on the stage. Bob, please come up.
Well, I've got to say, after the three people that were before me, I asked, what am I doing up here? There's no contest. But I am truly honored. I had a chance to look at the list of previous award winners for this award, and again, I said, what am I doing up here? I've had a wonderful time serving AIAA. And there's a whole bunch of thank yous I'd like to give. The first one is to my wife, who allowed me to go on these boondoggles to San Diego and Orlando to AIAA conferences. But I also have to thank my company, Engineering Systems, who paid for it. I can't argue with that. I think back on what I have done for AIAA, and that's fine, but what AIAA has done for me, and in particular, it has taught me how to lead. Not in the Air Force, it's easy to lead. If someone doesn't do what you tell them to do, you shoot them. It's easy. But in a volunteer organization, leading is literally like herding cats. But it taught me how to lead people that need guidance, and provided the guidance, smart people will do the right thing, and you rely on that. And so AIAA has taught me how to do that, and that has served me extremely well. I could go on and on about thanking people, and I won't do that, but I just want to thank all of you. I know many of you out there in the audience, and I'm totally honored and just amazed at getting this award. Thanks very much. Thank you, Sandy.
Congratulations. And I have to just say it's been a pleasure working with Bob all these years while I've been executive director. The next award we'll see will be the Public Service Award.
Established in 1986, the AIAA Public Service Award honors a person who has demonstrated sustained visible support for aviation and space goals. Recipients are often widely known outside of the aerospace community. Previous winners include Gene Roddenberry, Senator Barbara Mikulski, Dr. Neil deGrasse Tyson, Congressman Ralph Hall, and Kay Ivey, then Lieutenant Governor of the state of Alabama. This year, the award honors former NASA Administrator Major General Charles F. Bolden, Jr., United States Marine Corps retired, for his outstanding service and leadership to our nation's space program, advancing its economic competitiveness and ensuring the nation's security. General Bolden has had a remarkable career in public service. A graduate of the United States Naval Academy, he was a Marine Corps aviator who flew more than 100 combat missions in the Vietnam War, a test pilot attached to the Naval Air Test Center's Systems Engineering and Strike Aircraft Test Directorates, and an astronaut, piloting 2 space shuttle missions and commanding 2 more, including the mission that deployed the Hubble Space Telescope. He also served as Deputy Commandant of Midshipmen at the United States Naval Academy, the Commanding General of the 1st Marine Expeditionary Force assigned to Operation Desert Thunder in Kuwait, Deputy Commander of U.S. Forces in Japan, Commanding General of the 3rd Marine Aircraft Wing in San Diego, California, and as the 12th Administrator of NASA from 2009 until early 2017 under President Barack Obama.
People frequently ask about, what do you remember the most? What was the most exciting thing or stuff like that, expecting me to go right to space, and I don't. I actually returned to the incredible 34 years I had as a Marine. Among the most exciting memories that I have from the Marine Corps is the first time I did a pinnacle landing in a CH-46. The CH-46 is a tandem-rotored helicopter. I'm not a helicopter pilot, but I love helicopters and learned how to fly them. And a pinnacle landing is when you go out and you either take the nose wheel, it's usually a big precipice or a peak of a mountain or something, and you either take the nose wheel and you put it somewhere close to that so that something can happen back in the back, or you put the rear mounts on the pinnacle so that Marines can disembark, can go out the back. And I learned the critical importance of teamwork, because in a crewed helicopter in the Marine Corps, the critical person is the crew chief. And that's a young Marine, male or female, probably 19, 20 years old, who's sticking their head out the back and saying right, left, come down, come down, come down, and telling you where to fly that helicopter because you can't see. When you talk about spaceflight, being teamed with Sergei Krikalev and Vladimir Titov, 2 Russian cosmonauts, bringing their families to Houston, to a foreign land, a foreign environment, a different culture than they knew, and over a 2-year period of time living and working with them and trying to help them understand our culture and understand a little bit about theirs as much as we could, but through them from a distance. Public service to me has always been something that was critically important. I grew up in Columbia, South Carolina. My wife and I both did, and we were fortunate to have 2 sets of parents who were public service. They were school teachers, the height of public service. it was really drilled into us the critical importance of being willing to give of your time to benefit others. Every young person in this country should have an opportunity, if not be made, to do some type of public service before they get out on their own and decide that they're going to start focusing on what's good for them. I just think when you have an opportunity to serve humanity, to serve your fellow human beings first, and understand the challenges that other people go through, it makes you a better person. And I think it changes your perspective on how you make decisions that are going to impact you and your life.
So it's with great pleasure and delight that I invite our 2017 AIAA Public Service Award winner, Charlie Bolden, Marine astronaut, recent NASA administrator, to the stage.
Thanks so very much. Thank you. Thanks very much. Thank you. Let me start, but thank you. Let me start by congratulating the 2017 class of fellows. Incredible accomplishment. My fellow award winners tonight. I want to congratulate you also, and a special debt of appreciation to the teachers being recognized tonight. It was mentioned in my video. The person who has kind of swung on my arm now for almost 49 years, Jackie Bolden, my wife over here. She and I are both the proud products of public school teachers from Columbia, South Carolina. I also want to commend AIAA for another thing. I'm a counter. I'm not very good at it, but by my count, about 1/4 of the fellows inducted tonight were women. And while that's good, that ain't good enough. So I would hope that as we come out in subsequent years, that number will continue to go up. I'm going to spend my rest of my minute and a half because I want to thank people. First of all, Robert Lightfoot and Lisa Rowe, who are running America's space program right now. Absolutely incredible leaders. They're great engineers and scientists or whatever they claim to be, but I commend them for their leadership ability. NASA's in great hands now, and I tell people all the time when they say, who should be the next NASA administrator? I said, it ought to be Robert, but I don't want to poison the well, so I don't say that to very many people, but I think they're doing an incredible job. Jaewon Shin, who is here, Jaewon took us to heights in aeronautics where we tried to restore the field of the big A to NASA. And I think we were able to do that under Jaewon's leadership. And I want to thank another group in NASA that never gets mentioned, and it was alluded to in my comments in the video about the incredible experience of working with Sergei and Vladimir and getting ready for my last space mission, and that's the Office of International and Interagency Relations. I renamed it, and I can never remember what the OIIR stands for, but Mike O'Brien, Obi, who served both for Mike Griffin and me, absolutely incredible diplomat, if you will, taught me a lot about working with international partners, and now Al Condis, who is following him. And then the final person I'm going to appreciate you will recognize later on is Bill Gerstenmaier, who is just awesome. Absolutely awesome. And he is so because he's married to Marcia. So whoever Marcia had married would have been Bill Gerstenmaier. But since Bill married her, he gets the credit. I just want to thank you all so much for this recognition. I could have named tons of other people, but my NASA, my Marine Corps families, and my birth family, thanks so much to all who do what they do, and thanks to every one of you in this room for what you have done. Thank you.
Okay, the next award will be the International Cooperation Award.
Established in 1988, the AIAA International Cooperation Award recognizes an individual or individuals who have made significant contributions to the initiation, organization, implementation, or management of activities with significant United States involvement that include extensive international cooperative activities in space, aeronautics, or both. Past recipients of the International Cooperation Award include Graham T. Gibbs, Dr. Jean-Michel Contant, Dr. Scott Pace, Dr. Russell M. Cummings and Andreas Schutte, and Simonetta DePipo. This year, the award honors 3 individuals: Melissa B. Rivers, Research Aerospace Engineer in the Research Directorate at NASA's Langley Research Center; Dr. John C. Vasberg, a Boeing Technical Fellow and Technical Lead at the BCA Advanced Concepts Design Center, the Boeing Company; and Dr. Richard A. Walls, Strategic Tactical Advisor for the Advanced Air Vehicle Program, NASA Aeronautics Directorate, for their vision, leadership, and implementation of the NASA Common Research Model, advancing United States and international research collaboration on industry-relevant challenges in open forums. The trio developed the NASA Common Research Model, or CRM, to meet the international aerospace community's need for a modern, industry-relevant research model that could accommodate open and public geometries, process advanced experimental data, including data for high-quality computational fluid dynamics validation studies, and serve as an international standard reference wind tunnel testing model that enables comparisons between facilities. Walls developed the model's goals and characteristics of the transport configuration. Vasberg worked on the detailed aerodynamic design of the configuration, especially the geometry in the model, which was critical to its success. Rivers actualized the concept with wind tunnel tests and also established a NASA CRM website that is available to users of the model. Aerospace agencies from France, Germany, and Japan have used the NASA CRM, as have researchers from around the world who are continually working on areas of additional research and development for the model as they continue to refine it.
My mom always told me the first word I ever said was airplane. We were under a landing pattern from RDU. I knew I wanted to be an engineer. I loved the space program. I loved airplanes. I was going on college tours and I saw a wind tunnel with a model in it being tested at North Carolina State University. And I said, okay, that's for me. It brings a lot of things together.
I guess my journey did start when I was about 8 years old. We went on a tour of Kennedy Space Center, my family and I. And as we were getting off the tour bus, my mom told the driver that I wanted to be an astronaut when I grew up. He said, well, I'm sorry, but you can't become an astronaut. And once he said that, that was it. From then on until I got to college, I was determined I was at least going to work for NASA, and here I am.
Well, me getting into aerospace is kind of a long story, but I grew up on a farm in South Texas. I always thought that I'd go back and farm. My best friend growing up, their family ran a crop dusting outfit. So I was around airplanes my whole life. And so when I went to college, I wanted to study something interesting. I entered into the aerospace engineering department, knowing full well that I'd graduate and go back and farm. But as I got further and further into this, I really enjoyed what I was learning, and I realized then that I was going to have to give this a go.
The International Cooperation Award, it speaks directly to what we were trying to accomplish. You go all the way back to the beginning, even before the Common Research Model, or CRM. The beginnings with the drag prediction workshop, when we hosted NASA meetings to begin defining the Common Research Model. We were trying to figure out a way to have the community at large, across borders, internationally, assess the state of the art of computational fluid dynamics.
The idea was, let's develop a high quality, a contemporary transonic transport geometry that we could push out into the public domain. We would build a wind tunnel model for it. NASA would test it in multiple facilities.
We have taken it to Germany to test in the European Transonic Wind Tunnel. We have taken it to Canada to test in the National Research Council's wind tunnel.
The Japanese caught me in the hallway and said, "John, we want to build our own." Unfortunately, Rich and I sized it just a little bit too big to fit into their facilities, so they actually built their own at an 80% scale of the NASA CRM.
I believe the Common Research Model is contributing in a positive way. It's setting up a new model where we can share data openly. It doesn't have to be proprietary.
In order to accomplish something like the Common Research Model and the activities that we've done, it requires teamwork. It's not just Rich Walls, Melissa Rivers, and myself. There are dozens of folks spread out all over the world.
Collaboration, I believe, is important in the aerospace industry, so we can build off of each other's strengths and learn from others' mistakes.
Everybody's showing what they've done well and what everybody agrees with, but everybody's also showing where the disagreements are, and that leads to uncovering causes, and it helps everybody improve.
And if there's any lesson I've learned in all of this, there's no way any one person could accomplish something this monumental by themselves.
AIAA would like to invite our 3 recipients of the 2017 AIAA International Cooperation Award to join us on stage. Melissa Rivers, John Vasberg, and Richard Walls. Please join us.
All right. I was elected to start. This is an incredible honor. I mean, we just looked at each other and just went, wow. It's such a great feeling to be recognized by the AIAA, and as Sandy said earlier, being recognized by AIAA means being recognized by your peers, and there's nothing better than that. And as you saw in the video, this award is really about working together, and it's working together around the world. This actually started about 10 years ago, and it started in evening meetings at AIAA conferences. And people who know me know that I schedule a lot of meetings in the evenings at AIAA conferences, and a lot of things, good things come out of it, and this is probably the best thing that's ever come out of it. We started with a group of U.S. Aerodynamics leaders. I want to acknowledge people from the organizations, the Air Force, the Navy, Cessna, Beech, Gulfstream, Northrop, Lockheed, Boeing, and NASA. When we first created this model, I made the promise that we would do everything we could to actually build it and test it. And a couple people in the room made sure I wasn't a liar, and that includes Faye Collier and Ruben Del Rosario, who got us off on the right foot. And then we went into testing. Melissa will say a little bit more about that. Before I step away, I do want to say a big thank you to my family who's here. I couldn't be here without my family. And as kids get older, it's hard to get everybody in the same place at once. And they're all here tonight. And tonight we're going to take the best Christmas picture ever.
to follow on what Rich said, I would just like to thank the test team from NASA. There were several of us that traveled with the model to test it in different tunnels. Scott Goodliff, Ashley Dittburner, and Jim O'Shaughnessy really did the hard work. And I'd also like to thank our international testing partners, including JAXA, DLR, SAGI, NRC Canada, and several others. Without their cooperation, this would not be possible. And I'd like to thank my family, who, with their support, this would not be possible if they didn't allow me to go and test in different countries and in different tunnels. So thank you.
Folks, I have the best job in the world. And I get to work for the Boeing Company, and they actually pay me. Not sure how that worked out, but it did. In addition to all the institutions and folks that Melissa and Rich had already mentioned, I'd like to also thank pay special recognition to the Applied Aerodynamics Technical Committee of AIAA. They sponsored Rich and I to get started with the drag prediction workshop back in January of 2000. And a lot of good things have come from that. In addition to that, at the Boeing Company in particular, I want to recognize Rob Gregg, who is Chief Aerodynamicist of BCA. He was one of my strongest supporters in this endeavor, and he pushed me, and it's paying dividends. On more of a personal note, I have two gentlemen sitting at my table tonight, my strongest mentors, Bob Liebeck of the Boeing Company and Professor Anthony Jameson of Stanford University. I've known these gentlemen for 35 years now, and it's been a wonderful ride. And last but not least, I'd like to thank my beautiful bride, Claire Vasberg. She's been my biggest fan and swiftest critic when necessary. She's my moral compass and a true partner for this journey called life. Thank you all.
Congratulations. Thanks. Congratulations. Okay, our next award will be the Reed Aeronautics Award.
Established in 1934, the AIAA Reed Aeronautics Award is named in honor of Dr. Sylvanus A. Reed, a noted aeronautical engineer, designer of the first metal propeller, and a founding member of the Institute of the Aeronautical Sciences. The award is the Institute's highest acknowledgement of notable achievement in the field of aeronautics. The award recognizes those who have transformed how we think of flight. Previous winners have included Dr. Charles Stark Draper, Clarence L. Kelly Johnson, Bert Rutan, Dr. Ben T. Zinn, Dr. Ramesh K. Agarwal, and Dr. Earl Dowell. This year, the award honors Dr. Edward Greitzer, the H.N. Slater Professor of Aeronautics and Astronautics at the Massachusetts Institute of Technology, for his outstanding and sustained contributions to solving real-world problems in aerodynamics of propulsion components, systems, and integration, and for the development of successful collaborations with academia, industry, and government. Through his work, Greitzer has made numerous contributions to several areas of aeronautics. First, the dynamical behavior of complex aeromechanical systems. Second, understanding vortical flows. And third, the conceptual design of advanced civil aircraft, with the goal of moving the concepts up the technology readiness level ladder. His specific contributions to aeronautics include developing a better understanding of compressor instability, including the co-invention of the dynamic control of compressor instability. Unique and notable contributions to the understanding of mechanisms of inlet vortex formation, compressor inlet distortion, vortex mixing, and tip clearance vortices, and the conceptual design of advanced civil aircraft, including aircraft engine noise reduction.
I'm enormously pleased to receive the award. It's not only a recognition of peers, but it's maybe a connection of the respect and admiration that I have for a number of the past winners, some of whom I've been associated with. I got out of graduate school with a broad background in fluid mechanics and applied mathematics, but I hadn't taken any propulsion courses. However, at that time, Pratt & Whitney was hiring a number of PhDs. And what I found was a range of problems that were really interesting, a range of like-minded colleagues. That was an excellent education in what air-breathing propulsion was about, and also, being in industry, what it really meant to understand not only what, but the why of a given fluid mechanics situation, in the sense of developing deep understanding of a root cause. That's really what's needed to solve problems. MIT is a place that's about opportunity. So just in general, being at MIT has been a doorway to all kinds of interesting things, some having nothing to do with what I do day to day here. So my career has been one of interaction with industry and also being at university, basically going back and forth between the two. It's just a pleasure to work with people at MIT. There's a really great attitude. Wow, we can do this. We're MIT. So that pervades students, faculty, staff, and maybe the other aspect of that is that, at least in our department, there's a really strong feeling of collaboration. Let's band together to solve this important problem. The problems that are interesting, at least interesting to me, have different levels at which you can engage them. And universities are interested in different things than industry, but there's enough substantive overlap that you can certainly work together. What's the intellectual nugget in this particular project? And you can find them in just a host of things having to do with jet propulsion, fluid machinery, turbo machinery in general. And those things are very much the seed corn for academics, whereas industry is interested in different aspects of the problem. So there's making the product better, there's finding the intellectual nuggets, explaining something that hasn't been known before. That's why that works, and here's how now I can plug it back into the product and see how to make it better. There's a virtuous cycle there that I think it's a win-win situation for university and industry.
I'd like to invite our 2017 AIAA Reed Aeronautics Award winner, Dr. Edward Greitzer, the H.N. Slater Professor of Aeronautics and Astronautics at MIT, to the stage.
Okay, as was said, this is a great honor for me. Not only can I thank the AIAA for electing me to this award, I also thank the many people who reached out and wrote to me in support of it. The idea of connecting with the past winners, mentors, colleagues, although maybe it's a stretch to include myself in that group, is really important to me. And I just want to mention shortly that there's another aspect that makes this a special evening, and that's basically the many things that have happened with with this dinner that are really good reminders in a very positive way of my career. I'm sitting at the Pratt & Whitney table where I started my career. One of the people at the table is Dr. Del Rosario from NASA, who was a really strong and committed supporter of our work on boundary layer ingesting advanced civil aircraft. If you noticed, one of the pictures that flashed by was of me and Natalie Crawford, who was honored tonight as an honorary fellow. And I might mention that the people at the Pratt & Whitney table are longtime collaborators, another one of whom was honored as a honorary fellow. So this has been very enjoyable in that respect as well. And I said most of what I had to say in the video, but as I look out over the audience, I see the leadership of AIAA and the leadership of the aerospace profession, and a really good representation of the type of people who've created the sort of wonderful vision of the future that characterizes air and space. So with that, with you as the representative audience, I'd like to say thank you for the education, thank you for the support, and thanks for giving me the opportunity to work in this field. Thanks very much.
The next award will be the Goddard Astronautics Award.
Established in 1948, the AIAA Goddard Astronautics Award recognizes notable achievements in the field of astronautics. Endowed by Mrs. Esther Goddard, the award commemorates her husband, Dr. Robert H. Goddard, a rocket visionary, pioneer, bold experimentalist, and outstanding engineer whose early liquid rocket launches set the stage for the development of astronautics. Recipients of the award exemplify Goddard's dedication to expanding our ability to explore and understand the universe. Past winners include Dr. Theodore von Karman, Dr. Werner von Braun, Dr. Charles Alachi, Jean-Jacques Dordan, and Dr. Wanda M. Austin. This year, the award honors William H. Gerstenmaier, Associate Administrator, Human Exploration and Operations Directorate, NASA Headquarters, for his leadership of America's space flight program, commitment to international space cooperation, and inspiration of a new generation of space explorers. Gerstenmaier, known affectionately by his friends and colleagues as Gerst, has directed America's space exploration efforts since 2005, with oversight for the International Space Station, the Space Launch System, the Orion Crew Vehicle, Civil Space Communication Systems, and space launch vehicles, including commercial cargo and crew transportation systems for ISS support. He also oversaw the last 21 flights of the Space Shuttle program, including the system's retirement.
When I started my career at the NASA Lewis Research Center, now Glenn, I think back now on the first engineers I was assigned to work with, and they were the engineers that had wrote most of the textbooks that I had taken in college on aeronautics. And now I was getting a chance to work hand in hand with these really experts in these fields, and they were so nurturing and so helpful to me in my career. There wasn't a dumb question I could ask them that they wouldn't spend the time to answer. As I look back, I think about some of the experiences I've had, and they're absolutely amazing. You know, I've got to interact with entertainers, I've got to interact with presidents, I got to meet the Queen of England. These are things that I would have said, wait a minute, I'm an engineer, I'd rather be in front of a computer doing math and solving equations, but yet I get to meet with all these dignitaries and actually get to talk to many folks.
The H-2B has cleared the tower, the 6th HTV vehicle on its way to the International Space Station.
Being recognized as part of this big human spaceflight team has just been a tremendous experience for me. I don't spend too much time thinking back on my career because that's not important. I'm still looking forward. There's still a lot to be accomplished. I really have a vision for what we can do as a nation, what we can do in space, moving humans' presence into space, and what we can do with our crews. So I really look forward very strongly. When I go to work, there are no better people in the world than the people I work with every day in the office and the people I get to interact with. And that's what really motivates me. There's a sense of purpose that's higher than all of us. There's a sense that we all have to work together to make these impossible things occur. And that teamwork, that high performance effort that makes us all work together is just really, really special. So I consider myself blessed every day I get to go to work to work with this great human spaceflight team.
I'd like to invite a man who needs no introduction to the stage. Bill Gerstenmaier, please join us.
Again, I want to thank the AIAA and thank all of you for this tremendous recognition. And as you know, human spaceflight's the ultimate team activity. You know, none of the things mentioned in this award were possible without the support of a huge and dedicated team. And I'm blessed, as I said in the video, to be part of that team. When I think of the word team, I expand that definition to include my family, and as Charlie talked about, my wife is a special member of the human spaceflight team and has really made a lot of things possible for me. This is a very unique time in human spaceflight. There's more development activity underway today than was present during Apollo. We're designing and building the next generation of spacecraft and space systems. These systems will be used for decades into the future. This is a great time for new and young engineers and scientists in our profession to learn and develop along with the hardware. This opportunity for learning is rare in aerospace, and it's only possible maybe once in your career, so that new generation has a unique experience. And we, as part of the AIAA team and its members, we have an opportunity to mentor and to learn from that new generation of explorers and engineers and scientists that are coming online. I stress and underscore the word learn from them. I think we can teach them, we can be mentors to them, but we can also learn from that new young generation and really move forward into space. So I challenge each one of us in this room to take this opportunity given to us by this nation and exceed expectations and build a foundation for spaceflight that will amaze generations to come. Thank you.
The next award will be for the AIAA Foundation Educator Achievement Awards.
Established in 1997, the AIAA Foundation Educator Achievement Award recognizes K-12 educators for outstanding contributions to the continued study of science, technology, engineering, and mathematics among youth. Each of these teachers has had significant impact on creating the next generation of aerospace professionals who will shape our community's future. The award has honored more than 60 educators from the United States and Canada. Tonight, joining those past honorees are Kathy Biernot, St. Mary's Visitation School, Elm Grove, Wisconsin, for 11 years of teaching science to grades 5 through 8 and challenging students to continually learn and reach for the stars. Tracy Dodrill, Cocopomp Middle School, Scottsdale, Arizona, for truly exemplary contributions to educating and empowering students every day to pursue STEM education and careers. Alexandra Kindrot, St. Thomas High School, Kirkland, Quebec, Canada, for outstanding teaching and sustained excellence in the implementation of authentic teaching practices and AIAA initiatives in the promotion of STEM at the secondary level. David Root, Lyons Township High School, LaGrange, Illinois, for outstanding achievement in empowering students through the use of integrative STEM learning activity. And Kevin Simmons, the Weiss School, Palm Beach Gardens, Florida, for exemplifying what it means to be a true aerospace teacher through outstanding leadership and mentorship, thus inspiring students to achieve great things. Thank you for teaching, encouraging, instructing, mentoring, influencing, guiding, and inspiring students. Tonight, we are inspired by you.
And I have to say, we are really delighted to be able to honor some educators every 2 years here at this gala. What we do in the room, we inspire young people to come into the field. They're working with the young people every day to keep those aspirations real and help these young people figure out how to achieve those dreams. So I don't think we can honor educators too much. They really are an important part of our system. So before the script says hold your applause, but I would encourage you to applaud at will, okay? And we're gonna call them up one by one, our 5 outstanding educators. So the first awardee is Kathy Biernot, 5th to 8th grade science teacher at St. Mary's Visitation School in Elm Grove, Wisconsin. The next awardee is Tracy Dodrill, 7th grade science at Cocopah Middle School in Scottsdale, Arizona. The next awardee is Alexandra Kindrat, educator and educational researcher at St. Thomas High School, Lester B. Pearson School Board in Kirkland, Quebec, Canada. The next awardee is David A. Root, applied technology teacher at the Lyons Township High School and certified flight instructor at the Embry-Riddle Getz Aerospace Institute in LaGrange, Illinois. And the next awardee is Kevin L. Simmons, science educator at the Weiss School and founder Blue Cube Aerospace in Palm Beach Gardens, Florida. And we'd like to get a group photo before you leave the stage, so if you could join. Come over a little bit more, I think. Is this okay? Yeah, I'm going to go down over here.
Oh, I'm supposed to be down. I'm screwing things up.
When I was talking with our educators earlier, I told them that our community is very, very passionate about STEM and that we greatly appreciate what they do on a daily basis, so thank you for that standing ovation, because that proves my point. This is a near and dear subject to our hearts. While we're focused on the topic of education in STEM, and we're getting ready to move to our final award, the AIAA Foundation Award for Excellence, I can't think of a better time to unveil an exciting new collaboration that we are working with between the AIAA Foundation and the Boeing Company to inspire elementary and middle school students to explore STEM opportunities. We are proud to announce that we've established the AIAA Foundation first Legal League Team Grant Program, which is generally sponsored by Boeing. The AIAA Foundation will coordinate grants to offset costs to AIAA member-run teams participating in the first LEGO League elementary and middle school focused program. The hands-on engineering-based aspects of the first program are particularly resonant with middle school students, and this is a critical age to inspire future aerospace professionals. I've had an opportunity to judge one of those programs in San Diego a few years back, and I have to tell you, it was so fun to watch the students just try and figure out how to solve these problems, and their enjoyment when it worked, and their determination to make it work when it didn't work. If you ever get a chance to participate in any of these competitions and work with these students, I think you'll get a lot out of it. It's very, very fun. Plus, who doesn't like enjoying Legos and building interesting and new things with them? So it's good all around, right? We are very grateful to the sponsor, Boeing Company, for providing the resources and the vision to launch this new student program, and with the AIAA Foundation and the First Legal League. I want to acknowledge and personally thank Dr. Greg Heislop, who's the Chief Technology Officer of the Boeing Company, for conceiving of this collaboration. He wasn't able to join us tonight, unfortunately. He had to be off on, I think, the West Coast for some Boeing business. But we do have Ken Sanger here, who's the Vice President and General Manager and Deputy Program Manager of Boeing's KC-46A tanker program with us tonight, also a very engaged AIAA member. So thank you, Ken, on behalf of the Foundation. So for our AIAA community out there, spread the word, get your local members and your technical committee members engaged with mentoring some young people in this very fun, exciting competition at a really critical age, at the middle school age. And now our final award of the evening.
Established in 1998, the AIAA Foundation Award for Excellence recognizes individuals, teams, programs, or organizations for a current noteworthy accomplishment, extraordinary lifetime contributions, or unique accomplishments that represent excellence in the aerospace community, generate inspiration for the global community, and enable the betterment of mankind. Recipients of this award have demonstrated a commitment to solving complex challenges, unraveling the mysteries of flight and space, redefining the state of the art, and pushing the very limits of human capability through innovation, ingenuity, and collaboration. Previous individual and team winners have included Norman R. Augustine, Alan R. Mullally, the Joint Strike Fighter Program, the JPL Mars Science Laboratory, the X-37B Orbital Test Vehicle Team, and General John R. Jack Daly, United States Marine Corps, retired. This year's winner is the NASA Langley Research Center in Hampton, Virginia. It is being honored for 100 years of excellence in aerospace achievements, scientific discoveries, and technological breakthroughs. The Langley Research Center is the nation's first and oldest civilian aeronautical research facility. Authorized by President Woodrow Wilson in 1915, the National Advisory Committee for Aeronautics, or the NACA, studied the problems of flight to find practical solutions. The NACA broke ground in 1917 for the Langley Memorial Aeronautical Laboratory, which in 1958 became the NASA Langley Research Center. The facility has played an integral role in shaping our nation's aerospace industry. The technology and theories pioneered and developed at the center have included variable density, full-scale, transonic, supersonic, and hypersonic wind tunnels, low-drag, streamlined engine cowlings, airfoil characterization, and laminar flow and supercritical wing designs still in use on aircraft today, the swept-back wing, the transonic area rule, winglets, and the blunt body concept that is instrumental to our nation's space and missile programs. Today's airplanes are also lighter and more fuel efficient because of NASA Langley's breakthroughs in composite materials and structures. The center also played an important role in America's space program. Langley was the first home of Project Mercury, and the Mercury 7 astronauts began their training there. Equally significant, many of the leaders of Project Mercury and later the Gemini and Apollo programs were Langley engineers. Until the advent of these programs, Langley was not known to many outside the aerospace community. In addition to work on aircraft and spacecraft frames, controls, and systems, research at NASA Langley has advanced flight safety in other ways. Its researchers pioneered a grooved runway surface that improved the ability of aircraft to maneuver during takeoffs and landings, helped advance the ability of aircraft to handle in-flight lightning strikes, and found ways to mitigate the effects of wind shear on aircraft. Langley researchers have also performed critical work in the study of wing vortex formation and dissipation, helping aircraft avoid loss of lift when encountering those conditions. Today, 3,400 Langley employees and contractors work side by side a seamless team of innovators pioneering aerospace research and development, expanding horizons and opening frontiers for exploration.
The Foundation Award is about unique achievements or a legacy of inspiring aerospace contributions over time. You don't have to look hard to find both of these in the history of NASA Langley. Teamwork and collaboration are essential to our success. At NASA Langley, brilliant researchers work to solve astoundingly complex problems. But even the most gifted engineer or scientist can't get the job done alone. He or she relies on colleagues who test or help focus their ideas. They depend on the critical mission support professionals who keep the gears of the machine turning so that their research can continue. A timely example of this is the famous human computer, Katherine Johnson, whose trajectory calculations helped make America's first human space flights possible. Alan Shepard, John Glenn flew into history, but they needed Johnson's math and the computations of many like her to make it home safely. As technology, computational tools, and computer modeling continue to improve, the next 100 years will see amazing changes. Whether it be new kinds of spacecraft, flying machines like personal air vehicles, or other autonomous vehicles that can operate in the air, on the ground, and on other planets. I hope that people can connect those advances to NASA. When there are newly designed, innovative aircraft in our skies that are quieter, faster, safer, and cleaner, I hope they know it's because of NASA research. I'm confident that 100 years from now, the public will continue to be inspired, excited by NASA, our people, and the amazing things we do. We here at NASA Langley are humbled by this recognition and honored to join a truly elite group of other Foundation Award winners. The award is also special to us because of the heritage we share with AIAA. NASA Langley began 100 years ago in 1917 as our nation's first civilian aeronautical research lab and NASA's first field center. The AIAA began in 1930 as a group of science fiction writers dreaming of space flight, and over time, members of the organization have been involved with many important advancements in aerospace. A rich history of technical excellence and achievement link NASA and the AIAA. This award stands as a testament to that bond.
On behalf of NASA Langley Research Center, the 2017 Award of Excellence Award winner, I would like to invite Dr. David Bowles, the director of the center, to the stage.
All right, good evening. I know I'm the last thing standing between you and getting out of here, so I'll make my remarks kind of short. First of all, I want to thank AIAA for this very prestigious award, and I humbly accept it on behalf of NASA Langley Research Center. I do want to take a moment to recognize 3 of our former center directors we have in attendance tonight. That light is awful bright, but I saw him earlier. Delma Freeman is sitting over there in the corner. Yes, go ahead. Lisa Rowe is sitting back here. Let's give her a hand. And I know Steve Jerzik is here somewhere. Where's Steve? I saw him earlier. There he is. Okay. All right. I don't think I missed anyone, but if I did, stand up. The video kind of said it all. It's been a great place. Somebody earlier said they had the greatest job in the country. I tell people all the time, I got the coolest job on the planet. Just getting to come in the gate every day and help people do the great things you saw in that video. I really accept this award. It is a team sport. Other people have said that tonight. I accept this on behalf of all those people that made all those great achievements. And it's the people in front of the spotlight, the scientists, the researchers, the engineers, but it's also those people behind the scenes, the mission support people, those unknown hidden figures, if you will, that make all of this possible. They are part of that team as well. In our industry, academia, partners, a lot of which are here tonight, Y'all are part of that team that have helped us make these great achievements over these past 100 years. I think Ralph Waldo Emerson said, "No great achievement was ever made without enthusiasm." That enthusiasm has propelled us for the last 100 years to do the great things we've done. I am very confident the next 100 years will be even better, so thank you very much.
All right, well, that's a jam-packed evening. Get a lot in a little bit of time. I want to congratulate the fellows, the honorary fellows, and the award winners one more time. And while we're clapping, let's thank the staff of AIAA for setting all this up and working so hard. I'd like to especially thank Sandy for training me for the past year and helping me figure out where I'm supposed to go, why I'm going there, and what I'm supposed to get done when I get there. That's been a tremendous help. And mostly I want to thank my wife, Susie, for keeping the household and the family together and making this week much more enjoyable. With that, congratulations, and I bid you a great evening. Thank you.